Now, the astute among you will have noticed that just like with f of x all squared and 1 on f of x, there are some critical points, one of which is 0, okay, because the square root of 0 is just 0, okay? And of course the other critical point is 1. I should have said critical value. So it's 1, which is still about here, right? So the square root of 1, also 1, so far so good, okay? Now, then when you think about how it's going to behave after that, again, think visually, right? For example, you know what this value is, 3. So therefore, the transformed function should be the square root of 3, which is about 1.7, okay? So you're looking at somewhere just above halfway, okay? Now, even just from this very cursory drawing, you can see that it's sort of curving over this way, right? Curving over this way, which actually is exactly what you ought to expect, right? Because think about it like this. When we did our original y equals f of x all squared, okay? We identified our 0 point, we identified our 1 point, and then we said, well, it's going to do from here to here what all parabolas do, which is go upwards like this, okay? So this is like a zoomed in version of that, so that you can see it goes underneath, and that's critically important. Well, because what you're looking at here is the inverse version, the inverse function of squaring, okay? Instead of going underneath your original curve, you're going to go just above, right? At least in this little area here between 0 and 1. And then you're going to go off and you're going to do your normal thing, okay? Because this graph has discontinuities in it, by the way, it's got an endpoint, you should describe how it ends. Can x equal negative 1.5? Can it exist there or can it not? Do you have this scenario? Or do you have... Well, let's try it, shall we? X equals negative 1.5. See what happens. Y equals the square root of 2x plus 3, by definition, which is the square root of 2 times negative 1.5, which is negative 3, plus 3, which is the square root of 0. Does that exist? It does exist, right? It's 0. So I need to describe that on my graph with a filled circle. It must be filled in. Okay? Whenever graphs end, and they don't just keep on going forever, you have to say how they end. And if we had determined for whatever reason that it couldn't actually exist at that point, of course you would give it a hollow circle instead. Okay, last one, very quickly. You think, whoa, oh no, we're doing this modifying y business again, which was so confusing before, okay? But remember I told you there was this link between 8 and 9, right? What's the link? Think about it. Yeah, if you take the square root of this, right? Because the y squared is over here, I'm going to have to slap a plus minus over here, right? So therefore, all this is just that, which we already know looks like that, okay? That's the positive part, y equals positive, square root of f of x. But now I also need to include the negative part, which we looked at. It was the very first question we looked at this morning. How is it different? It's the reflection across the x-axis. And you're like, oh, of course, because it's just this guy, right? Which you're sick to death of. These are just the sideways parabolas you looked at in the locus, right? So, of course, it should look like that. That's what you would expect.